There we go. All right. Well, might hear a few more beeps as people join, but we'll probably go ahead and get started. So a bunch of material to get through, and we're going to leave 15 minutes at the end for Q&A, although if you do have questions, you can use the chat. We definitely want to answer questions as we go. So if you have a question, you might as well get it into the chat queue. Let me bring up the chat window. There we go. So for those that have joined, thanks very much. We're going to spend the next hour going through our object solution. We're going to focus on one of them. We have a few object solutions. But before we get started, my name is Andrew McKay. I'm the president of Superna, and with me is Derek Manning, who's our CIO, and working with a lot of our customers on object solutions. So maybe just bring up the agenda, Derek.
Yep.
So this is the order we want to go through the material. So, objects been around for a while, but we thought it'd be good to go through some Object 101, just some bullet points on how objects are different than files. And then we'll talk about some use cases, but one of the big use cases is, of course, identifying data that would be better served being stored in an object format, which is usually a lower cost way to store data. And then we get the question a lot, so we'll talk about tiering and golden copy and what's the difference. And then we'll go into some of the considerations around use cases and evaluating a solution. And costs, there's always a cost associated with storing data in object format. So we've got some material to go through there, and then some use cases in Q&A. So that's the agenda. We'll go ahead and get started. So I'm going to turn it over to Derek. We'll start off with just going through some 101 sort of what's important to know about objects.
Sure, thanks a lot. So we've got a number of slides coming up that will go over some of the details of object storage. But when it comes to newer technologies or evolving technologies that I get introduced to, sometimes I ask the question why. And it's easy for me when I can kind of humanize or personalize the technology and see how it interacts with what I've done in the past and how it works with my current daily life. And object storage is a really good example of that. So when we first started talking about object storage, I think the first time I was introduced to it was probably in an earlier version of OpenStack. We were looking at a storage container, and I didn't really clue in as to why we would need such a thing. I was used to files and file systems and file structures. What was object storage's place? Where did it fit in my data's life cycle? You look back at traditional file systems and where they came from, why we started calling bits of data files and folders, that the whole hierarchical structure and how the data is being organized. It really simply just comes from traditional data storage. Pre-computer era, we would stuff files into folders, and then we would put folders into drawers, and drawers in the cabinets in the rooms. And anytime we needed to find data, our data was organized in such a way that we could get into a file by looking at a cabinet location and a drawer and a folder, and then pulling the file and getting access to the data. And that seemed to work for a long time, and in fact, it was exclusively how I was conditioned to interfacing with personal computers, and in my personal life and in my work life. Throughout that that time, I found that I was having a lot of problems organizing my own data as we started getting our cell phones and digital cameras. Started looking at the way I was organizing all of my vacation photos or photos from the day, and how I was accumulating more and more of them. And I was using the traditional file organization thinking. And that's, I would give the file a name, or just have it in a folder as a named DSC or whatever it was. Like I would use a program to rename the files so that I would be able to actually go in and browse through a folder and organize the folders by date or vacation trip name or something like that. And over time, early on it worked well, but then over time it became very difficult to manage all of that data myself. Trying to find a photograph of somebody from some time, if the name got skewed, then there'd be a problem finding it. Thankfully, when we look at JPEGs in particular, there's a header in there that can be populated, and a lot of my earlier stuff wasn't. But the metadata tagging of the files really helped me to find things. And then eventually that wasn't enough, and we had to get programs that were overlaid on top of our photographs in order to find photographs from a location or a particular date. And that really helped as well. But still, the problem was very difficult with trying to manage all of that generally unstructured data. I was structuring data that doesn't really need to be structured, and that started taking up a lot of my day, just organizing that. And similarly, I think enterprises are finding it very challenging to efficiently and affordably store data. IDC's putting out numbers that suggest perhaps up to 80% of all data worldwide by the year 2025 is going to be of an unstructured type of data. And I had to step back when I looked at that number, because I think of, we've been kind of storing data, growth has been exponential, but over time, for 50 years, maybe, or 40 or so years anyways, 5 decades of storing data. And how is it possible that object storage is such a new concept, but perhaps 80% of data might be object-based, in the next few years? But then you think about, some of the applications that we have that I mentioned, like, taking photographs with our cell phones, but, emails, photos, videos, that's all consumer-based type objects that would grow in numbers. Applications like, Instagram or TikTok or whatever it is. If you think about the workflow that goes into storing that data and how that data becomes presentable, I don't think it would be possible for some of that data to scale out and be accessible by so many people. You would have to store your file, organize it, and then tell some software where that file was. So these larger companies are using these unstructured techniques to essentially just drop all of the files into, we won't call them files, we'll call them objects, but they just drop them into a flat space, and then have the application or another application above it abstract that data and present it out to you in a way that you don't have to worry about organizing where that data is and how it exists, when it expires, et cetera, et cetera. So enterprises as well, that's like the consumer space, but when we look at some of the newer emerging technologies in the enterprise, so ADAS systems with immense amounts of sensor data, logging data, and utilities with their metering, it's a real challenge to efficiently and affordably store and manage data. So this is where object storage kind of comes in and helps us out.
Yeah, so let's go through some of the basics, Derek. Let's get just through some of the.
Right. With object storage, objects can store basically any type of data. We have a limit on the maximum size, but we don't have a folder limit anymore. So we don't have to worry about browsing and looking through mountains of data to find objects. It's all abstracted by another layer. There's the ability to read ranges of data within a single object, so you don't have to open the whole object itself. Writing objects, there's no particular updates to existing objects. There's no random I/O to objects. We've got Dell supporting extensions for updating objects by range. With high performance copy and download. So the next slide kind of gets into that. In traditional file systems, if you wanted to download data, you'd connect to the file and then stream the data downwards. This next slide kind of shows that with object-based file systems, you can spawn a tunable number of threads to download and read objects in parallel. So perhaps thread, in this example of 3 threads, thread 1 would read bytes 0 to X, and thread 2 might go X to Y, and thread 3 would go Y to Z, and then the data would be reconstituted at client side once the data was downloaded. So you can now gain the benefits of higher throughput by multi-threading your reads. So objects in this file sense have 3 main components. There's the object name, which is a unique identifier. You name the object, and then you've got the metadata for the object, and then you've got the actual object blob or the object data itself. So this is the metadata property here, where you can store up to I think this number that's quoted, the 2K metadata size, is specific to Amazon S3. It's an HTTP limit, but you can have up to 2K of metadata stuffed inside of alongside of your object blob. So this could describe the data, what it is, and really give you the ability to search metadata to find and locate the objects, because obviously if they're named uniquely, we didn't get into that, but object blobs must have a unique name, and quite often these names in some other solutions are kind of random characters. With Golden Copy, when we store to object stores, we maintain the original name so that you can browse with any typical browser, but that's not really an object storage thing. You can assign a class of or tier per object as you're uploading objects. So objects can be discretely assigned cold or hot or archive-based classes as you're uploading to the object data store. So in objects, we have the concept of buckets. So buckets would be like a root path to data, and the bucket is a flat space that you can assign different credentials to and assign access to, as well as you can also assign data lifecycle properties to be globally applied to all of the objects within the bucket. Multiple buckets can be grouped together, so you can apply different policies at the bucket level. And you've got just a bucket naming limit, 364 characters, and usually lowercase and no special characters there. But that's just basically for the root of your object space. Authentication. So S3 uses an access and secret key pairing. This just goes into details of the number of characters per access and secret key. Azure and Google have their own methods, which are listed on this slide too. We don't have to go into too much real detail here on that. So permissions, you can see that the object permission scheme, if you're familiar with traditional file system based permissions, it's a lot leaner in its current incarnation. But you have the permission to read. It's pretty much straightforward here. But this slide basically differentiates between what happens when a permission is applied on a bucket as opposed to when it's applied to an object, and which permissions can be applied to either buckets or objects. This is pretty self-explanatory on this slide. Protocol security. So the question may arise, well, what happens when I'm moving my data into the cloud? So HTTPS is supported, and it's actually recommended so that you can have ensured in-flight encryption of your data, so it's protected from site. HTTP can be used and is supported, but definitely you'd want a solution that uses HTTPS. So Superna Golden Copy does use HTTPS for secure in-flight transfers. Checksumming of data integrity. So automatically being able to compute and compare the source to what's in the target to ensure that the data that's stored in target is the exact same piece of data that you intended to store, and it's not corrupt. And then this allows for integrity checking as well, so you can run ND5 integrity scans on your target data and make sure that your archive is exactly coherent. And then versioning, so the ability to store multiple versions of an object. So this supports updating if when you go to store an object, the object doesn't exist, a new object gets created, but then when you try to store again, and if you've enabled versioning, then the old version gets pushed back into a list, and then the most recent version is presented. The ability to store end versions of an object that can be configured as well. And then lifecycle policies can be applied so that after you exceed a certain amount of versions, the older version is automatically tidied up. And of course, all versions are available for download, all at the same at any point in time. You can select your version. So how do you do you want to take this one or?
Sure. Yeah. So, object storage is used at the moment. Its big use case is archive and backup. So we'll cover that one for sure. It's got many use cases. Its use cases are growing, but one of the biggest challenges if you have a large file system is identifying the files that are good candidates to archive. I think you went back a slide, Derek. There you go. So there's averages and things where, easily 50% of a file system is rarely accessed. So the challenge is finding out which files in the file system. And so of course, in millions and hundreds of millions of files, the best way to do that is with an index. So last access time, that's the ultimate way to identify files because that's telling you if someone's actually opened the file recently. Last modified is going to be your next most accurate way to identify that data. And of course, if you don't have A time turned on, then you don't have much of a choice. But we have a few options. So we've got search and recover. It can index the file system metadata, and it can run reports. That's what we would recommend, of course. There's many ways to identify your data. Maybe you already know where it is. Maybe it's laid out in a project folder. In any event, if you go to the next slide, we have a report that's designed to simplify the whole process, either last accessed or last modified. And it will graph out the data based on the quantity and the month and year in a table below. So that's going to tell you what year or month represents the highest value to locate on disk and then start to plan out some sort of an archive plan. And so that's what this feature does. Once you identify that age range, then you can actually zero in and get a complete file list. And then once you understand that, then you have to understand who owns the data. Maybe it's department-based data. So this is a graph. We can cover this in a different webinar, but this is a big use case for us in terms of how to identify data that's growing old. And there's a particular feature within search where you can export the search results and then we can import that over into Golden Copy, and so we have the ability to hand off the copy job over to Golden Copy. But we'll just spend a bit of time here because we get this question a lot. So Cloudpools is a feature on the Isilon. It's a stub-based solution. So what's the difference? So a Cloudpool solution is more in line with a tiering solution. So you might have a tier within your cluster, like an A series node tier in your cluster. Cloudpools is just an external tier, and it's going to use object storage to store that data. And what it will leave behind is a stub file. That stub file allows users to transparently open that file the way they normally would, and that file will get automatically inflated. The data in the object store is compressed and encrypted, so that's obviously a huge plus, especially if it's off-site in a cloud provider. But that data isn't directly accessible. It's designed to be inflated on demand through access through that stub. So you get the benefits of an external tier, you get transparency to the end user. You're not really removing the data, you're not archiving the data per se, you're storing it in a lower cost way. So wouldn't classify it as an archive solution. If we go to the next slide, Golden Copy is a copy. It is a byte for byte copy of the original file. The data, when it lands in the object store, is usable, which means you can access it with any S3 browsing tool. There's several. There's CyberDuck, S3 Browser. There's a number of tools. But you can access that data independently of Golden Copy. You can read it, you can write it, you can download it. You have full access to your data. So that's one key difference. The other is the ability to change the tier. In a Cloudpool scenario, you need the data to be on-demand recalled. So in a tiering solution, meaning tier within the cloud provider, you can't use the tiers like Glacier and Deep Archive because that requires a recall first, and then you can inflate the data. And so that wouldn't really work in an on-demand transparent solution. So if you're looking for the lower cost options, then you need the ability to leverage the tier in the cloud provider, so like Glacier or Deep Archive. And Golden Copy allows you to access all of the features. So tiering, immutability, locking, encryption at rest, and all those types of features you can access because we're copying the data in natively. So that's a key difference right there. Do the two work side by side? Sure. We've got customers that are going to use Cloudpools because they need to offload the data and they want the transparency. And in other use cases, they have data sets that they don't want on the cluster. No one needs to access it, and they want to copy it off and delete it and then save that space on the cluster. Golden Copy can copy, but it can also recall. Recall is the process of bringing the data back onto the cluster, and because of our permissions metadata protection feature, we can actually recall things like owner, group, the mode bits, and even the folder ACLs can be brought back. So you're not losing any of the critical metadata in the copy process. And then, of course, checksum, so data integrity is built in as well. And then copy and sync. So copy is a copy, and then sync is a continuous incremental, and that's using the Isilon change list. So much like SyncIQ, we have the same sort of incremental always sync capability with Golden Copy as well. If we go to the next slide, Derek. So we just look at some use case comparisons just side by side. We can do backup use cases with Golden Copy. We can do archive, not a tiering solution, that more in the Cloudpool scenario. And DR, we actually have some simple DR type use cases that we've published. This is around AWS S3 and Azure, where you can actually mount your data after it's been copied into object format. So not really any overlapping use cases here. They're two different methods to solve different problems. So we go to the next slide. So when we talk about decision criteria, when looking for a solution, well, the big one that comes up a lot is how is it licensed? And a lot of solutions like to license by the terabyte. Obviously, that gets very expensive. The format, if you're if you have a native format that you don't need the solution to decode it for you, that's obviously preferable. Point in time snapshot. So if you think about backups usually copy file by file, but what's the better solution in a file system is to copy all of the files at a point in time. And that would be ideal. Databases. Usually you have a database to track what was backed up. That's additional infrastructure that you require. That's a pretty common requirement. Ideally, something that can self-describe and is database less, lowers the cost of that solution. Rate limiting. Obviously, if you're going to the internet, you've got to rate limit your bandwidth. So that's a pretty basic feature. And then tiering, having access to all the features of your target storage without any limitations is ideal. That way, there's no handcuffs. You can leverage every cool new thing that is developed on the target storage. You don't want to be limited with whatever solution you choose. If we go to the next slide, just sort of lined up, how we stack up against this criteria. So licensing model, I think most customers like a flat rate. They want predictable costs. They don't want to have variable costs tied to the amount of data that they own. And so we have a flat rate licensing model with Golden Copy. So that's obviously going to make it pretty predictable. It's one price for a cluster. It doesn't matter if it's a 3-node cluster or 100 nodes, it's the same price. The format, I mentioned already, we don't change the format of your data. So your data is yours. You don't need our product to recover it or access it. You can access that directly. The format that we encode the metadata is standards-based. It's using the headers inside the property of the objects, and that's common against all targets. So it's AWS, Azure, ECS, Google. The format is the same across them all. And then we think this is a big deal, that if you're going to back up data, I don't want to back up data as it's being changed, because now my backup really isn't a point in time anymore. And so Golden Copy leverages snapshots in the cluster. So we're going to copy the data from a snapshot. So we're literally getting an entire file system down to the second, because ISO snapshots take a second to be created. So now we can back up that exact point in time without worrying about the files that are being changed as we're copying. Self-describing, so there's no database with Golden Copy. So the data is self-describing, meaning the metadata we need is built into the object format itself. Rate limiting is there as well, and full access to the tiering options. So you can store the data at the most cost-effective cost point. Next slide. So cost. I think, Derek, you're going to go through some examples. I guess you could bring up our actual calculator as well.
Is it presenting okay?
Yeah, it's a bit small, but I think it's still visible.
Do you want to run through the... So it is a challenge calculating exactly how much data, how much money it's going to cost for you to get data up and into the cloud. And we've developed a tool to help you understand what the cost of the data is going to be, both with API call and actual storage. And this is all based on a particular tier that you're selecting for an archive task. And we've developed this so you can just log in to the tool. We'll provide a link and then punch in a couple of numbers like what your initial data set is going to be, your total file count. This helps out in millions with the the number of API calls that is going to happen. How many of them are larger files and how many of them are smaller files? So so we can just put in like 90% of my files are greater than in a particular bucket, and then what my estimated data growth is monthly. So once we put in all of these numbers, we can run an example, a simulation on what the cost might be. I'll put that in. These are just some smaller numbers to put in, but we'll just start with that. And then we get an idea of our initial cost. I don't know how that's showing up on the presentation. Is it clear, Andrew?
Yeah, it's visible. Yeah.
Yeah. Okay, so we get an idea of, this was a small example, obviously 1 terabyte start and 5% growth month over month, with 90% of my files being greater than 10 megabytes per second. But we get a complete breakdown of what the storage cost is going to be month over month. And this we have this in just to really help you understand what the cost of storage in the cloud will mean to you as an estimate.
Yeah, if we just go back and maybe just run through the same scenario with, go back to the tool and we'll
Sure.
just, the default to remember here is the standard tier, and this is in the, in AWS. So this assumes that you want instant access to your data at all times. So that's going to be the highest cost option. So if we try Glacier next, and we'll run that same scenario. If you're using this tool, run through all the different tiers. You can just leave the same info here. And the important thing about this tool is it's designed to calculate the way golden copy copies. So that's another key aspect of this. So you can see it show you the lifecycle transition cost, because there's a cost to move it from the standard tier into Glacier. And if we run that back again, just do it again, we'll just go to Deep Archive. The difference between these tiers is Deep Archive is going to, or Glacier, we'll start with Glacier. Glacier is going to require you to recall the data first before it can be recalled by golden copy back into your file system. And that is, I don't remember the exact range, it's in the hours range in Glacier, and it's into the, I think it's a day plus with Deep Archive. So obviously you have to factor that into what's your use case. If your use case is pure archive, then Deep Archive makes tons of sense. If it's always on, need immediate access to your data, then obviously standard tier. But this can be mixed and matched. We have the ability to copy into different buckets. So really it depends on what the data type is, and you can configure golden copy to put the data into various buckets depending on what type of data you're dealing with. So this is free to use. You can of course set up meetings with sales as well if you have a specific scenario that you want help with understanding.
During testing, we found that some of the the choices you'd make without a cost calculator may not be exactly what you expect. So the real benefits of the cost calculator to get you in line with understanding what the cost could be. We found in one particular case that selecting what we thought would be the cheapest tier of storage actually amounted to a higher cost because of the life cycle pattern that we were following with our data. We were destaging, in our example, destaging cold data, and there's a cost associated with that. So with the calculator, at least you can see and get a better idea of realistically how much the costs are going to, what your cost might be for archiving. I think I went backwards. So with golden copy, there's some target use cases. Number one use case is like, you just want to archive data and recall it if you ever need it back. Another use case is just backup and DR to the cloud. A legal hold and compliance use case. So like putting on enabling worm mode on the bucket. So that's one of the immutable, the features is to enable an immutable attribute to some of the objects that are pushed up, so they be held and locked and uneditable for a legal compliance period of time. Cloud copy, tiering, lock, legal hold, cleaning up snapshots on site. So consolidating your snapshots, and you'd make a point in time copy in the cloud with golden copy, and then consolidate your snapshots to free space on your existing high tier infrastructure, your Isilon. With number 6, it's like creating a master copy of a data set in object compatible storage format. So you just want to have that presentable to applications as objects. This is a good use case. And then there's the one and done example where you might have a folder and you just want to do a one-time copy on it and put it away and keep it immutable. So one of the benefits in using in our solution here at Golden Copy is that when you are archiving to the cloud, we archive from a snapshot, so all of the data is frozen at the instant that you start your archive. And essentially what that means is as you're archiving, if your archive task with a traditional system took 3 days, and over the course of 3 days, perhaps data would drift 3 days. And then now your data that's archived into the cloud, now it has this substantial drift in it. With the method that we use, it's an exact point in time copy of the objects, so you know that they're all frozen at that moment in time. So key features are small, medium, scale out deployments, any size of environment, and PowerScale using it as an integrated tool to sync copy to a storage bucket. Scheduled or one-time time of sync data. It's like number 7 again, and then S3 PowerScale direct restores with permissions. So when we recall, when we store the actual ACLs, ownership metadata that gets stored along with the object in the metadata component. When we recall, we actually reapply that data.
So we'll just take a second here. So right now we have the base Golden Copy product. So copy, sync, some copy reports, but we're really building sort of more use case focused solutions. And the first one we're going to be focusing on is some automation and more specific backup use case. So there'll be a Golden Copy Advanced license, will be optional. You can add it on. It's going to target more directly the backup use case. So for example, version-based recall feature where you could give it a date range and it will review all the versions during the recall process and bring back versions that meet your criteria. APIs, you want to orchestrate the copy or movement of data. So you'll be able to create copy jobs through an API. More focused reporting on backup use cases. So roll-up reports and a full GUI reporting option. And then more direct integration of tiering support right inside Golden Copy. That's the ability to define the tier you want the data in right inside Golden Copy, and the data will be copied directly into that tier. And then, of course, on the recall side, how do you get the data back out if it's been placed in a tier? Well, then Golden Copy will retrieve it from the tier first, then it will recall it, back onto your file system. So want to go back one slide, Derek. So this, we're targeting April for that advanced license. And before I move off of this slide, we've got a number of other products that support object storage. So Search and Recover is coming out in the first half with a release that will support object storage indexing. So now you have file and object indexed and unified search within Search and Recover. On the search product as well, we also already, and have for a while, supported Cloudpools. So Cloudpool stub reporting is fully integrated into the search product today. And we have plans to integrate Golden Copy with our ransomware defender air gap strategy. So that would give you the ability to have some data going off in object storage, some data going off into an Isilon air gap, and the ability of ransomware defender to control Golden Copy's ability to copy or sync. So we're integrating Golden Copy into our air gap solution. So now you can kind of pick and choose what types of data go where and how you decide the air gap. Okay, we can move on, Derek. Thanks.
Okay, and this is the next set of slides just kind of goes over the process and how Golden Copy copies data up to either as a cloud-based S3 bucket or your private on-site S3 target, which would be your ECS. We are parallel in the way that we transfer. So we spawn up multiple threads on S3 sync, and we span across multiple nodes for both data and recall. We're load balanced across your S3 target, whether it be cloud-based or private on-prem. We mentioned before that we do store in a format that is non-proprietary. So if you do connect to your bucket, this is a standard S3 browser. Once you connect to your S3 target and then browse into the bucket, you'll see a file structure that looks familiar to traditional file-based systems. Although this is in an object store, but you can browse in to extract using just an off-the-shelf S3 browser. You can browse and extract individual files if required, or confirm data is in place and audit as well. So yeah, as mentioned just earlier, we do load balance on both ends. So as the Golden Copy is represented in the middle of the slide, on the left side we've got your power scale, on the right side we've got your S3 target. This is, in this particular case, it's ECS with a load balancer. Oh, sorry, this is our internal load balancing. So you don't necessarily need a load balancer in front of your ECS. What we can do is we establish multiple NFS connections to read the data from your power scale, and then we establish multiple S3 connections to your target to load balance across multiple data nodes and get the data copied in parallel much faster. We've got our deployment architecture here. Again, this is this particular example has us with a multi-node. So our scale-out performance, which is optimized for massive numbers of files. We can deploy Golden Copy as a single node. We've got 3 flavors that we offer: single node small, single node deep, which has extra CPU and RAM capabilities, and then we've got a scale-out deployment that employs what we call virtual accelerator nodes. So we have multiple worker nodes that connect to NFS and S3 and execute your archive tasks in parallel. Here we have a slide that demonstrates the virtual accelerator nodes and how we're optimized for small file performance with object-based. So rather than files underneath a certain file size, we can optimize our transfers by executing files that cannot be multi-parted. We send them up in parallel as individual objects. Larger objects get multi-parted by multiple threads that we have, but smaller ones, when we can't multi-part, then we use multiple nodes to upload. So we've got the recall now diagram. This is when we're restoring from object store. We support multiple modes of recalling. We can recall do a redirected recall into a different folder. We can also recall to a totally separate Isilon cluster, and the advantage of that is in a disaster recovery scenario, you really wouldn't need, you do not need an extra license to recall to the extra recall only cluster. Andrew mentioned earlier that our licensing is based on source cluster, but not on target cluster for recalling. Is there anything on this one, Andrew, you wanted to add?
No, I think that's good.
Okay.
I'm going to leave some time for questions.
Yeah, and
we're running up against the end of the hour, so.
Yeah, this one just shows integration with search, how we can leverage Superna search and recover to identify data that should be archived. Andrew had the slide up with the example of age data. We can export that list of results to Golden Copy, and then task Golden Copy with archiving that data, and then at which point an administrator can be confident to purge or lifecycle the data that was the source. That's it. Yeah.
Yeah. So I guess we can probably open it up to questions. There was one there about Azure Calculator, which I think we indicated that is on our roadmap to look at that as well, to assist with the planning or costing out a solution. I touched on a few sort of future product plans. This is actually a good time to talk about it. So object storage, is been around for a while, but its use is growing from what we can see inside enterprises, especially around ECS. And one thing we've identified is that object storage security solutions, largely don't exist. So the first thing we're planning to launch is ransomware defender for object storage. And we've built a prototype. There's actually a YouTube video off our product page, but we plan to add support for monitoring all of the I/O going to your object storage, looking for bad behaviors, and the ability to shut down access to the object store. So expect to see that and more information about that coming soon. In the same arena of security, auditing doesn't really exist either for object storage. So we plan to enhance our auditing product to also support ECS and offer a full range of auditing solutions around your object storage. And that's really just sort of the beginning of some of our object storage solutions that we plan to release this year. So Ransomware Defender is on a fast track solution. And later on this year, hopefully we'll be looking at the auditing solution as well. I see there's a question here, DR use case. Yeah, I don't know if, Derek, you can go to our manuals webpage. We can bring up the exact location here. So we published 2 solution guides on one, how to configure DR to AWS S3, and you just go down to the Golden Copy folder at the very bottom, expand it, and then go down to the bottom, solution guides, expand that, and you can grab the first one there, second from the, this is the Azure one. So we've got one for Azure, one for Amazon S3. Basically, what this allows you to do is you'd sync your data into the object store in the cloud, and then this procedure allows you to re-expose it as file data that's mountable over CIFS. It could be NFS, but CIFS is what we used. And there's an Azure solution and there's an Amazon solution. So yes, you can target a DR solution. Now, would it be your entire file system? No. Would you target an application where you would want the ability to run it from the cloud in the event that you had to? That's the way this has been documented. You'd pick some subset of your data and configure it so you could prep it and easily convert it into a mountable share. And we have other product plans in this area as well. But yes, we've documented how to do that. And so that's clearly an advantage when it comes to leveraging object storage. The benefit of being able to potentially mount that data and use it without recalling it. Obviously, that's a time saver, right? The time to recall the data back on premise would be slow, but this gives you a quick, rapid recovery option where you could mount that data from a virtual machine running out in Azure or Amazon. I could certainly handle some more questions. One thing, it's not fully in place yet, but we're going to be sending out a notification, once it's firmed up. But essentially, we're partnering with Amazon on a program that would allow customers to try out some copy to the cloud. And obviously that would be with Golden Copy, we'd be assisting and going through a proof of concept. So we'll have more to say on that, but trying to lower the barrier to get experience or hands-on, or take a look at how file to object type solutions can be deployed and how you might be able to leverage them. So once that's firm, we'll actually be sending out a broadcast where you can sign up for that program. So that's coming soon. Any other questions? Object storage, use cases? Any use cases that you didn't hear about today would be good. We're always interested to hear what use cases or problems you might be having or need help solving. Tools to identify eligible data for archive. Yeah, so that's our search product. We touched on it earlier, but our search and recover product is designed to index your entire file system. It does support content. So if you need content indexing, it does that as well. But essentially, it can walk the tree. It indexes the metadata in your file system. So the date stamps, created, modified, last accessed, and so on. And then we can run a search against that. And that's what this slide here is showing. It's showing the analysis or the output where it breaks down your data by month and year and tells you how much data was modified in that year or accessed in that year. And that's really the first step for any project to understand how much data you have that's archive eligible. No, it's not related to Easy Auditor. Easy Auditor is consuming audit data. And that's when you just touch the file system. What you're actually looking for is the data that no one's touching, right? It's the opposite of auditing. Auditing is the data that's active. It's the data that isn't being touched. That's the data you need to locate. And that's what the search product does. And they're showing an example here where it's breaking down the data. It gives you a graph so you can kind of mouse over it and see what % of your data has been touched and how long ago. And then the table at the bottom can be dumped into Excel. And from there, you can start to make decisions on, what data you want to target for archive or use cases. And then you can actually drill into it. So here we're actually just running a secondary search to then locate the physical data on disk and where is it that's not being used. And then you can dump that out to a CSV as well. So all the tools to kind of do what if scenarios is built into the search product, which is available now and used a lot for this one use case. That's a very big use case. In fact, our next major release of search is actually going to let you automate the analysis of looking for aged data, and will email you reports, much like a showback report. It'll email you the data that's being aged. You could set that up on a department folder. You could set that up on a project folder, and automate the reporting and actually send it out to end users. So you can send out reports that look like this on who owns the data, what type of data do you have. So fully automated searching and reporting is what's coming in the next release of Search and Recover. But of course, there's other ways to identify aging data, but this is our method. And it is integrated with Golden Copy. As I mentioned, you can take a search result and hand it over to Golden Copy, and then it can copy it, because Golden Copy is path-based copying. But with the integration with search, it allows you to copy data based on any criteria you want: age, file size, owner. All the attributes of the file system can be used to generate a search any way you want. And then you can just hand that file over to Golden Copy and it can go and copy it. So for anyone that wants more information, not that hard to reach us. So I'll just put the email in the chat here, sales@superna.net. More than happy to set up one-on-one discussions, go through this in more detail, proof of concept, all of those things, pricing, any question you have about what you've heard about today or want to follow up, just email us at sales@superna.net and put that email in the chat, and we'll be happy to follow up with you. We have a couple minutes left. If you have questions, now's a good time. This will be recorded and posted online, so for everyone that couldn't attend, we'll provide a link to play this back later. Well, as many of you are probably all on back-to-back meetings, and you have a meeting at 10, you've got 1 minute to do get something to eat. So, thanks everyone for joining. Like I said, we love hearing from customers, ideas, product ideas, use cases, love use cases. We try to solve as many problems as we can. So email them to us, however you want to get them to us. That's up to you, but thanks again for joining, and stay tuned for our next webinar, which we do have a schedule coming up in March around DR best practices. We have 3 coming up scheduled, so they're time zone friendly for Europe, North America, and in Asia. So we will be publishing that very soon on our webinar link on those sessions that are coming up around DR, because we get a lot of questions about DR. All right, thanks very much. Thank everyone for joining today. We'll wrap this one up.